Hi, so I'll be reviewing chapter 2, statistical learning. I've got my notes in here. So the focus is on building predictive models based on data. We've got a Y variable of sales that we want to predict, and we've got a couple of features: TV, radio, and newspapers. So we want to know, can we predict sales using all three features? Finding a good f of x, what is a good value at a given point? So if we'd have f of x and we want to know, if we plug in a value such as 4, what would be our y variable equate to? All of this leads us to us determining an expected mean, which is an expected average. And we've got a regression function that can actually help us get that. We need to take note of an irreducible error. Even if we know the f of x, we need to be cautious that there will be some errors in the prediction. Then we've got nearest neighbors, which can be quite loud when p is very large because of case of dimensionality. This is when your data set has many features inside of it, which can cause a bit of issues. Then we're looking at parametric and structured models. So a linear model is an important example of a parametric model. And then we also have a thin plate spline regression, which is a method that is useful for 2D spatial data. Thin plate splines are not easy to interpret compared to linear models. Then we can assess the model accuracy. Suppose we have some kind of f of x to some training data, and we wish to see how well it's going to perform. So we can compute something called an average squared prediction error. So this can be quite biased towards overfit models. So instead, it's recommended that we use fresh test data to avoid that issue. Then we move over to the bias variance trade-off. So when you have a machine learning model that fits the training data very well, but the predictions that make with new data is quite terrible, that leads to something called overfit. So the whole idea is that the training data fits very well, but there's a high variance because it does a bad job with new data. It's quite a low bias. And then regularization is a solution to bias variance trade-off, because it reduces how sensitive model is to training data. Then lastly, it's discussing chapter 2 discusses classification problems. So how we can build a classifier and assign a label from a given C point to a future unlabeled observation. And then there's an example of a biased classifier which has a smaller error in population. SVM can also build structural models for a given C value. That's a brief summary of chapter 2. Thank you.